this topic will be very helpful for the GATE exam. And let me start the session. These are the table of content we have. In the we shown that supervised learning, model evaluation, neural networks, unsupervised, and summary. Let I explain it clearly. So here let me start the linear regression. We know linear regression is nothing but it is one of the machine learning topic, and I think you definitely develop a regression model, right? So next, our goal is to fit a line that best predicts the continuous target value. It means we need to the linear regression will be helpful for the predicting a counting numerical value. That numerical value we need to predict, right? That so for this the closed form becomes this is the form for the closed relation form. The gradient descent will be iterative updated, and the rigid regression is nothing but L2 regularization. This helps to prevent the overfitting occurs. And next, the logistic regression. For the logistic regression is nothing but it used for the classification and regression tasks also. For the mainly the logistic regression is helpful for the binary classification. So in the binary classification, this will be helpful for the predicting the probability. So here this is the formula for the function. And next, the sigmoid function will be that here we shown that this is the sigmoid function, and next one is the decision boundary. It predicts the class 1. Here we shown that this is the decision boundary form that 0.5 it must be greater than of 0.5. Here this is the formula for the log loss of the cost function. Next one is KNN, K nearest neighbors. The KNN will be follow up that it helps to find the distance matrices Euclidean and Manhattan related problem. This is the formula for the Euclidean root over sigma of xi minus y whole square. The Manhattan formula becomes a summation of mod of xi minus y, and it helps to find the nearest items we have by choosing the value of the k term. Then we got the nearest and the highest values. For overfitting condition, the becomes high variance. For underfitting condition, there becomes high bias. So this is the vice versa conditions we have. Next, so Navy Bayes classifier. The Navy Bayes classifier, this is the formula for the Navy Bayes classifier, and its assumption with the features are conditionally independent given the class. It means the features are conditionally independent with the given classes. For example, key concepts are Laplace smoothing. Add 1 to numerator and mod v to denominator to avoid zero probability for unseen features. It helps to further smoothing the values in that position. The gate key is estimating the parameter for k binary features and c classes. The parameter becomes 2 into k into c. This is way we need to estimate in the gate exam for the parameters. For example, if a question is given, then estimate the parameters of the binary. This is the terms. Then we apply this multiplication formula. Then we got that question. Next, linear discriminant analysis. So in the linear discriminant analysis, the project data to lower dimension to separate classes is the Fisher's criterion. The Fisher's criterion means maximize the ratio of between class variance to within class variance. So it means SP is nothing but it is used for the numerator term is used for the between class variance, and denominator term is used for the within class variance. So next one is and here we shown that the classes are clustered tightly and far apart. It means these two classes are tightly clustered, and the key point is the linear discriminant analysis is a supervised, and it is unlike that PCA. The principal component analysis used for the decomposition purpose, but LDA is not like that. It is helps to project the data into lower dimension into two separate classes. It helps to project the data into lower dimensional spaces to separating the classes. You need to understand this point, very important. Last 2024, this question is happened. The linear discriminant analysis helps to separating the classes to the lower dimension, right? It is a supervised. This is also one important point. Assume classes are normal distributed with equal covariance. Next, support vector missions. Find the hyperplane separating classes the maximum margin. So the support vector mission helpful for that maximizing the margin. So separating the classes with maximizing the margin. This will be helpful. The hyperplane condition formula becomes W power t x plus b is equal to 0. The margin width formula becomes 2 by mod w. The optimization formula is minimize the 1 by 2 mod w whole square. The support vectors are data points closest to hyperplane. Here, this is the support vector helps that it helps to closest to the hyperplane. Only this affects the model. This way the support vector helps to affect the model. The concepts are soft margin and kernel trick allows misclassification. So the slack variable helps the soft margin and kernel trick help for the maps nonlinear data into higher dimension. It helps to map the nonlinear data into higher dimensions. Next, decision trees. The decision tree goal is split data recursively to create pure leaf nodes. Yes, it helps for that splitting the data recursively to create pure leaf nodes. And next one is metrics for splitting. For the metrics for the splitting is nothing but entropy. H of s is nothing but minus summation of pi into log to pi. 0 is nothing but a pure term. Here this is the formula for the entropy. Actually, you think that this is shit. This is very crucial and we got to understand. But this is very easy topics. If you remember as a important topics only, not completely dependent on the formulas by choosing them, and there is a fear by choosing these type of formulas. But we need to understand the main important points. So that important points in this page is the goal is what is the goal? The decision tree goal is splitting the data recursively to create a pure leaf nodes. It means that decision trees, the decision trees will be helpful that you need to make a decision perfectly based on the certain conditions, right? So at the certain conditions we follow that overfitting and underfitting problems. For the overfitting and underfitting problems we need to follow up that. So we for the fitting we upload that some approaches. That approaches is one is entropy and another one is information gain and the third one is Guinea impurity. This is helpful for that splitting the data recursively in the curate pure leaf forms. Next, bias variance and cross validation. These bias variance and cross validation are helpful for that. The bias variance trade-off is nothing but it is helpful for that calculating the total error. And next, we know machine learning we have the main important problem is overfitting and underfitting problem. How we need to solve this them by applying different regularization techniques that helps to resolve the overfitting problem. For the underfitting problem, we applying that increasing the IBS. For the IBS related problems, we have that the underfitting problem will be occurred. So the model will be too simple. For the I variance, that we got that overfitting problem. It means the model will be too complex. So we need to balance them by applying the regulation techniques and approaches. Different approaches we follow. So that's why this cross validation will be helpful. That what will happen in it. So leave one out is nothing but we need to leave a specific term to help. It helps to that n on n minus 1 test on 1. It means one is on test set and remaining one is for n minus 1 is training set. By splitting these terms, then we at this time then we got the condition as low bias and high variance. But it is expensive. Next, k-fold split into k parts. If we split into k parts, if a k is equal to 5, balance is bias and this way we applied the cross validation as a k-fold. Next, multi-layer perceptron. The multi-layer perceptron is nothing but it is a feed forward and it is for the back propagation. Here we show that is the back propagation. The activation functions are the ReLU, solves the vanishing gradient problem, and it is for the sigmoid scratches to of 1. For the software function is set to multi-class probabilities. Here this is the activation functions we have. The multi-layer perceptron will be helpful that the feed forward and back propagation followed and the activation functions. Mainly we use that ReLU as the activation function. Then after sigmoid function. Then third option we have multi-class probability function as a softmax. Gate key point is a single perceptron has no hidden layer, cannot solve non-linear problems like XOR. So it means the XOR gate related problems we need to solve multi-layer perceptrons by applying that. Because in the single layer perceptron there is no hidden layers. That's why we can't solve that. That's why in the multi-layer perceptron we definitely solve the XOR conditions. So this way we applied the multi-layer perceptron related problems. Next, clustering. We know very well what is meant by clustering. Clustering is nothing but grouping. So by grouping them, we have certain some conditions. The conditions become k-means, k-medians, and hierarchical clustering. K-means is nothing but it is sensitive to outliers. This point is very important. It means it cannot identify the outliers and to detect them. There is no chance to detect this. But in the mediates, it is in the robust to outliers. That way it was designed. And next one is hierarchical clustering. For the hierarchical clustering, the follow approach is agglomerative approach is followed. It is nothing but a chain like clusters is formed. Then after complete linkage, the maximum distance will be followed up here. The spherical cluster will be happened in it. The average linking is nothing but the average distance will be followed up here. The gate key is know how to read a distance matrix and match. It means we need to read the distance matrix and matching them. So at that, so we have 10 data points, right? In these 10 data points, 4 are in the one region and remaining will be in the another region. So we need to group them 4 as a separate one and remaining then group into another separate region. That is nothing but the clustering. These are the different methods we have in the clustering methods. Next, principal component analysis. There is a chance to get a question in this principal component analysis. The goal of the principal analysis is preserving the maximum variance. The projected the data onto axis preserving maximum variance. It means we need to project the data on the axis by preserving the maximum variances. So the following steps are: mean becomes 0. Compute the covariance matrix. After by computing, we need to find the eigenvalues and eigenvectors. So for the covariance matrix. Then after sorting them, then we got that maximum variance. The properties of the principal component analysis is it is an orthogonal. Principal components are the orthogonal, and a variance ratio becomes this. This is the variance ratio. If you want all these materials completely, so then come to Google Chrome, then search Surya Wave. Then here we got the first website. So let enter into this website. So here we shown that all these resources. Then click sign in. After signing with Google, so then click explore services. Here we shown that all these services are available in this website. So GATE 2026 complete bundle material is available here. Click get started. Then you got the all material access here. Then click on purchase now. Scan this QR ID with your mobile. After scanning this QR ID, then the UTR ID will be generated by after payment will be done. Place this that UTR ID at this position. Then click submit for verification. Let I enter this one. Then the payment will be verified within 20 minutes. Complete resources are available into your dashboard.